Good afternoon, everyone. A very warm welcome to all the participants joining us for this session of the Faculty Development Program on Design, ECT for Net Zero, organized by NIT Patna. We are delighted to have your continued participation and enthusiasm as we move into yet another insightful session focused on building climate resilient and user-centric urban environment. It is my pleasure to introduce our speaker for this session, Dr. Venkatesh Raman, Assistant Professor in the Department of Architecture at Gaya Engineering College, Bihar. Dr. Raman holds a PhD in architecture from NIT Patna and brings a strong interdisciplinary approach to his research, focusing on urban morphology, outdoor thermal comfort, and sustainable planning, particularly in composite climate zones. He has several research papers exploring the relationship between urban form, user perception, and environmental performance, with a specific focus on Indian cities like Patna. His work is especially relevant to today's challenges in smart city development as it brings environmental design principle with user-centric analysis, offering valuable insight into making cities more livable, climate responsive, and sustainable. In today's session, Dr. Raman will present on topic quantification of the non-physical factor affecting assessment of urban thermal environment outdoors, where he will discuss how physiological and perceptual response of users influence the evaluation and design of thermally comfortable urban spaces. Please join me in warm welcoming Dr. Venkatesh Raman. We look and
Thank you, Shum, Doctor. Uh, Thank you for inviting me to this valuable session. Is my topic quantification of the non-physical factors affecting assessment of urban thermal environment outdoors. Usually, thermal comfort studies started well in the 7th, 8th decade of the last century, around 75 to 80. But outdoor thermal studies were very lean during that time. The outdoor thermal comfort studies have started mainly by the turn of the century, that is 21st century. Most of the studies, the citations that you will see in my work will be post 2000, starting from before that. A few sporadic studies have been done, very valuable studies have been there, but most of the outdoor thermal comfort studies have started in the new century. But then most of the studies centered around controlling the urban thermal environment itself, with a focus on the morphology, microclimatic factors, etc., etc. Very few of them focused on the non-physical aspect, that is related to the human existence, the subjective factors that man carries while he traverses in any thermal environment. After say 2005, 2003, 2005, certain researchers focused their attention on the non-physical factors also, like psychological factors associated with the human thermal assessment, but most of them were qualitative. As far as I have seen, maybe a couple of years ago, till that time, I can say, I could not see any thermal comfort research which related to the quantification of the non-physical factors. I'm not sure about the last 2 years, 2-3 years. So I have taken up this study to quantify the non-physical factors that share a substantial percentage, maybe not much, but maybe 15 to 20% of the thermal perception is explained by the non-physical factors. So my topic basically contains 4 points. One is the urban thermal environment. Second is assessment. Third is factors affecting the assessment of the environment. That factors may be physical as well as non-physical. I will have a brief discussion of the physical factors also, since non-physical factors cannot be discussed in isolation unless we have a brief view of the physical factors also. And then the fourth term is quantification. Qualitative studies that have so far been conducted in terms of the non-physical factors were so far indicating the existence, the very importance of the factors, but quantification was yet due. So here is an overview of the presentation. We will first a very brief refresher of the thermal environment. Then we will see the assessment approaches of the urban thermal. My discussions will be based mostly on in terms of the outdoor environment, not the indoors. Most of the researchers, most of the speakers in this session I have seen have been speaking on the indoor thermal controls. My study about the outdoor thermal controls. Then factors affecting the assessment, physical as well as non-physical, and then quantification. So with that, a brief discussion about the thermal environment, the effectors. Two kinds of effects. One is controllable, the other is non-controllable. Uncontrollable. Uncontrollable factors, the global climate based on the location on the earth. You see this equatorial region, red color, warm, humid regions, dry regions, polar regions, icy regions. As we move away from so the macroclimate depends on the location on the earth, altitude, topography, soil conditions, etc., etc. These are provided to us by nature. We cannot control them, but yet they affect the urban design, the design of buildings, the design of urban reality. This macroclimate basically consists, there is a two-layer classification of the atmosphere. One is the urban canopy layer, which extends up to the average rooftop. Average means if there is some multi-story or some two-story, so you take the average of the buildings and this extends up to the average height of the building roof. The upper layer, that urban boundary layer, this extends say 10 times the average roof height. But this urban boundary layer affects the urban canopy layer, and the urban canopy layer affects the urban boundary layer. It is mutual. The upper layer is mostly homogeneous, while the lower layer is highly heterogeneous. It represents mosaic of microclimatic conditions based on the morphology of the urban area. And there is one transition layer in between the two, that is, this is an explanation, the 4.45 times the average building height. This is highly heterogeneous. This is like a transition between the upper homogeneous layer and the lower heterogeneous layer. So, I think this tab is coming here. If I hide it, I don't know if there will be some garbage, but let it be there. So, the interrelationship between the three, microclimate, urban morphology, and microclimate. Microclimate provided by nature. Urban morphology, we have been teaching our students to follow the this climatic data of radiation, temperature, etc. And based on that, we design our buildings. We design our cities, which in turn affect the microclimate of the place. So microclimate is a function that the urban thermal environment. We are basically concerned with this layer of the urban canopy layer, which we call microclimate, which varies, which may vary from one building corner to the other, or maybe it may vary in a matter of few feet, while the microclimate is a general statement of the region, bigger region. So the urban morphology is affected by the macroclimate, while microclimate is affected by both urban morphology and macroclimate. Our concern as architects and urban planners has been since last few decades to control the urban morphology in such a way that the microclimate becomes conducive to the human living. But outdoor environment, this is about the significance, why outdoor environment is important. It has, mostly in the, as I said, in the last century, the focus of the climatologists and thermal comfort researchers had been on controlling the indoor environment of the buildings, which later they realized that no, it depends, the indoor environment cannot be controlled properly in an efficient way, in an economic way, in a passive way, unless the outdoor environment is controlled properly. Few researchers like Allisins, this and one Humphrey, this Humphrey and Nicole. This is a very significant equation which represents, this is just to show why outdoor environment is important. The
Excuse me,
overall
sir.
comfort, yeah.
Sir, sorry to interrupt you in between, but your slides are not changing, sir.
Not visible?
Not changing.
Hello?
Not changing, sir.
Not
Slides are not
changing?
changing. Yeah.
Oh, you could see a change?
No, sir. I think you need to reshare it again.
Oh,
I think you have shared some specific screen, that's why it's not changing.
just
We can see your PowerPoint presentation all apart, but not in a slideshow mode.
which slide can you see now? The topic outdoor versus indoor thermal environment. Can you see this?
Sir, currently
No.
I can only just give me a minute. No, sir. Currently your screen is also not visible.
Oh. Please give me a moment. I will share it again. Optimize for text and images. What do you want to share? Optimize for text and images. Optimize for motion and video. Should I click this? Optimize for motion and video. Okay. Here now I have shared it. Window. Presentation. Here.
Now your PowerPoint presentation is visible to us with slide number 5, but not in a PowerPoint mode.
ना वो तो मैं कर दूंगा.
हाँ.
Now can you see the first slide, the topic?
No, sir. No, sir. We can see only your PowerPoint thing without slideshow, and this is 6th slide only.
Right now I just changed it, but then
when you click on share screen, you will get first option with automatically optimize and screen. After selecting automatically optimize, you will get down. There is a part click screen. Just click on that part, so your slideshow will also be visible.
Option I'm not getting actually. Stop video share. Here. Optimize for text and images, optimize for motion and video. I'm getting.
Automatically optimize is the first part, then the optimize for text and images and optimize for motion and video.
That option is not coming.
Then okay.
More playing virtual, yeah.
और सर उसके बाद देखो नीचे सिर्फ स्क्रीन का पार्ट आ होगा, वो होल स्क्रीन सेलेक्ट कर लीजिए रादर देन सेलेक्टिंग अ स्पेसिफिक स्क्रीन।
Screen. Windows.
सर अब एक बार स्लाइड शो
Can you
मोड में
say?
कर
Can you?
लीजिए,
Can you? Huh?
एक बार आप स्लाइड शो मोड में करिए।
दिख रहा है?
तो स्लाइड शो मोड में नहीं आ रहा है सर आपका प्रेजेंटेशन, ये पीपीटी की जो नॉर्मल लेआउट है उसके अंदर आ रहा है।
तो ऐसा करता हूँ मैं, इसी को इंक्रीज कर देता हूँ। स्लाइड शो मोड में नहीं आ रहा ना?
यस सर।
ये नहीं दिख रहा है, अभी नहीं दिख रहा है। स्लाइड शो मोड में किया, अभी नहीं दिख रहा है ना?
नहीं सर, स्लाइड शो मोड में दिखाई दे रहा है सर।
Screen. By the way, नॉर्मल ये विदाउट स्लाइड शो स्क्रीन दिख रहा है क्या?
यस सर, यस सर, यस सर, ये दिखाई दे रहा है सर।
तो इसी पे बढ़े फिर।
ठीक है सर।
Okay. I can't see any option. Say no. There is setting option in the computer. Still weak in this thing. Wait. Wait. Kids were helping me. They are not here. नहीं आता है। इसी पे पढ़ते हैं फिर।
ठीक है सर।
So I was kind of here. This नहीं दिख रहा ना?
स्लाइड नंबर 5 इज विजिबल सर।
अजय 5 स्लाइड नंबर 6 अभी ऑन है, प्रेजेंटेशन मोड में नहीं दिख रहा ना?
नहीं सर, प्रेजेंटेशन मोड में दिखाई नहीं दे रहा है।
फिर ऐसे ही बढ़ते हैं, चलेगा?
सर वी कैन रादर गो विद दिस, इट्स फाइन।
Okay, so let us proceed with this. Now I'll maximize the size of it. So we were here on this slide, outdoor versus indoor thermal environment. The significance of outdoor thermal environment in affecting the indoor thermal environment. These equations provided by Humphrey, this was in 1998. Overall comfort temperature given by this equation. CO is the outdoor temperature. So you can see that indoor comfort depends on the outdoor temperature also. This is for framing building. This is in terms of outdoor and indoor temperature. This is a composite comfort temperature. So this is all to show that outdoor environment is affecting the indoor environment. So what are the drivers of the urban environment? We will have a couple of slides discussing on this. Basically, whatever we see in the urban environment, from large buildings to small shrubs that might have sprouted by the side of the curbstones, that all are affecting the urban environment, thermal environment, but with varying significance in terms of hard and soft surfaces. If we talk, the buildings are the greatest factors of the urban thermal environment, while vegetation in terms of trees, shrubs, hedges, etc., are also affecting the environment. But buildings have been reported to affect the environment maximum. But contrary to the common belief, the buildings are always emitting heat in the terms of long wave radiations, absorbing short wave radiations. That's true, but there are two aspects of it. Buildings can worsen the environment as well as they can enhance also the thermal environment by enhancing the wind flow, like corner flow, wind channeling. These are terms which we use while planning large urban blocks, not in case of individual buildings, but when buildings are put together in such a way that they conform to the prevalent wind direction, they can help in improving the wind flow and ventilation of the outdoor environment by wind channeling. In addition, buildings provide shading. So we have heard of urban heat islands, but there is also one term, urban cool islands. So as compared to the open spaces, which may be high Bowen's ratio, etc., the open field, and it's based on the research. I have seen one research which shows that open lands are warmer, hotter than certain urban environments, built-up environments, because urban environments provide shading, they provide proper wind channeling, there are vegetation, etc., etc. So buildings can have positive and negative effect on the urban environment. That is all intended to say. Certain characteristics, right? T and RH, these two factors are the most inert factors as regards to the controllability in the urban environment. Since due to the advective mixings, you cannot control TA and RH. You can, but you can control radiation and the wind. So but then to certain extent, built forms and built up surface to volume ratios are said to control the TA and RH also. This is reported by the researchers. Orientation and aspect ratio. You see, if you orient your building along the for sun, or you may orient it for the wind. Incidentally, there are places like Patna where orientation for sun and wind are in concurrence with each other, so it becomes easier for the planner to plan buildings such that you get advantage of both. So this orientation aspect ratio will control your radiation. On the other hand, the buildings can retard the ventilation, obstruct thermal flow, and create wind shelters. This is one example on the right side. I have taken this snapshot from one MLA quarters, which is located on the east of the, you see this High Court building. Can you see my screen now? Is it visible, no?
Yes, sir, it's visible.
You can see my cursor also, I hope.
Yes, sir, yes, sir.
So here is the High Court building. On the east of it, these are MLA quarters. Whosoever the architect, they have oriented in this building in such a way that wind penetration is zero. The easternmost block blocks all the wind, and this whole area becomes like a hot pan. And this I have simulated, and I'm saying this based on my simulation. This, had it been oriented east-west, it would have been good for solar as well as for wind purposes, but I don't know why this has been done. So this kind of mistakes are being done. I mean, this is a carelessness. I cannot say mistake. These are adding to the urban heat island effect of that. So these has to be avoided. Then the effect of trees. trees also, like buildings, have positive and negative effects. It's a misconception that trees will always provide you cooling. They can heat the environment by emission of long wave radiations. They can block the wind. They can, kind of compared to any open area, the trees if placed wrongly can create negative effects in the urban environment which goes beyond tolerance. So the purpose is that buildings, trees, etc., and trees compared to other vegetation, they have been given a maximum significance. They provide shading. Apart from evapotranspiration, cooling by evapotranspiration, they provide shading also. They are responsible for wind channeling also. So the trees layout has to be done in a very meticulous manner, considering all these things. Maybe by before planning these things, you need to simulate the things in terms of the existing climatic conditions. And so with that said that about the thermal environment, we will quickly switch over to human assessment of the urban thermal environment. The main purpose of my presentation is focusing around the human, not the urban environment. Urban environment I have just mentioned, so that it cannot be discussed in isolation. The human assessment of urban thermal environment outdoors, it involves certain psychological, subjective, physical, physiological, etc. other parameters. What are those? We shall see that in the coming slides. Human assessment of thermal environment has been defined on three fronts. There are three approaches. One is physiological approach, purely physiological, based on the firing of thermal receptors in the skin and the signals sent to the hypothalamus in the brain. Here, we have to note that human existence has two parts, the body and the mind. On the other hand, mind also has got two parts, the objective mind and the subjective mind. Objective mind is responsible for scientific calculations, mathematics, physics, etc. Subjective mind is for assessment of arts, feeling of the environment. Assessment of the thermal environment is based on the subjective part of that brain, not the objective. While this first definition, the thermophysiological assessment, is anchored on the sensation sent to the objective mind. So sensation, this thermophysiological assessment will be mostly same for every individual, not changing. If 40 degrees centigrade of your temperature there outside, it will be 40 degree. That assessment will be same for everybody. The second definition, energy-wise, exchange between the human body and thermal environment is based on the exchanges between the two. The exchanges we know based on convection, radiation, etc. So this definition says that this is a heat balance equation. This S, the stored heat in the body, should be equal to 0 to achieve a thermal comfort. That's the very essence of this definition. These are metabolic heat, work, heat lost in work, and then ACRE are the various modes of emission of heat from the body by conduction, convection, radiation, evaporation, etc. So the sum total of heat generated minus heat lost in work and minus heat lost by these processes should be equal to 0 to achieve the thermal comfort. But the person who proposed this concept, that is P. Fenger, in 1973, he himself has contradicted that just maintenance of heat balance is far from being a sufficient condition for thermal. So this definition also proves to be inadequate. The third definition is the most versatile and internationally accepted, probably US ACHRA in American Society, the full form for heating refrigerant engineers. So this definition is given by Ashraf. It emphasizes on the condition of mind that expresses satisfaction in the thermal environment. It is assessed by subjective evaluation. Subjective evaluation, again I repeat, we have two hemispheres of the mind, objective and subjective. Subjective mind is responsible for the subjective evaluation of the thermal environment. This definition is anchored on that very concept. So, by dint of this definition, thermal perception, thermal comfort becomes matter of subjective assessment. It does not remain an objective assessment alone. Objective also is there because you have to sense the heat through the thermal receptors. Heat sensation तो स्किन के थर्मल रिसेप्टर से ही जाएगा माइंड में, बट उसकी प्रोसेसिंग जो होगी, द प्रोसेसिंग दैट विल बी डन इन द सब्जेक्टिव माइंड विल बी बेस्ड ऑन सेवरल other factors which in this study we call non-physical factors. There are others also, personal factors, subjective factors. So subjective aspects become very important as per this definition. Before proceeding, let us be clear about some terminology: sensation, perception, and assessment. There are three terms. Sensation is a purely physiological activity. Sensation of a 40 degree centigrade of air temperature outside will give same sensation to maybe an Indian or maybe a Russian. While perception wise, a 40 degree centigrade may be tolerable to an Indian. It will be maybe a Russian may have to be taken to hospital, may fall ill, fall sick. That's because of his past subjective knowledge that he carries with them. That knowledge is thermal experience, expectation, etc. We shall see it later. So, perception is a synergistic function of environment. Of course, environment comes the first, then the human body, the thermal receptors, to which the human body is the gateway through which the sensation enters the mind, and the subjective mind. So these three factors combined together give an experience of thermal environment which is termed as perception. That way, thermal tolerance is one term. हिंदी इसकी कहते हैं तितिक्षा. तितिक्षा मतलब सहन शक्ति. Thermal tolerance can vary based on individual subjective factors like expectation, past experiences, the thermal environments where a person has been to in the past. And expectation means if it's a month of June, we know the monsoon has not come yet. So tomorrow it will not rain. That is our expectation. So tomorrow we will not get up in the morning and say, oh, आज तो बहुत ज़्यादा हो गया, पानी नहीं पड़ा, because we are not expecting that. While during the monsoon seasons, every day the weather becomes unpredictable. Every day we expect कि आज पानी पड़ना चाहिए और नहीं पड़ा, तो बहुत ज़्यादा परेशानी बढ़ जाती है because of that expectation factor. You are expecting rains to fall, while during months of May and June you don't expect, so you are okay. यह तो होना ही है. Then the assessment. Assessment, if you search the Google, assessment will talk only of a measurement, objective measurement. While in reality, if based on other researches, what I am claiming here is based on other researches that assessment is not only objective measurement of the thermal environment, but subjective evaluation also of this objective measurement relates to the environment, while this subjective evaluation relates to the human subjective factors. Now, as we said, subjective factors are associated with perception. So how can you call them assessment? So what is the difference between perception and assessment? So The answer is perception is an individual experience, while assessment will be a generalized statement of different perceptions by, say, a group of individuals processed in some statistical manner to give a generalized statement of that thermal environment in terms of the subjective factors. That will become evaluation rather than, but measurement and evaluation combined together, we will call that assessment here in our present discourse. So environmental assessment can be done using thermal comfort models होते हैं, PMV, PET, outset, UTCI. There are several 156 thermal comfort models are existing there. Most of out of that, these four are most. The maximum used are of these four: PMV, PET, outset, and UTCI. These are the four most used thermal comfort models. While so these thermal comfort models will explain only the thermal environment, not the subjective part of the human. So how to assess that subjective part? For that, we will go into multivariate regressed models, incorporating as many number of the subjective factors as you want. So this is basically this is a procedure proposed by 110 and NIT 2012 में. So this is the any thermal comfort study should incorporate at least 4 stages of observation. One is physical. Physical is about the thermal environment. Physiological relates to the human body. Body means body, not mind. That body can be an obese body, it can be a slim body, it can be tall, it can be black, it can be white, it could be whatever. So it's all about the body. It's different heart rate, different pulse rate, different perspiration rate. So those are the physiological aspects. Usually these physiological aspects are very accommodate very less in the thermal comfort because of the practical inconveniences. Like if you conduct a transfer survey where the number of respondents becomes in thousands, so you cannot measure each and every person's core temperature, pulse rate, heart rate. So this is less important in thermal compression. But then these two aspects are called static and objective, while these psychological and social behavioral these are called dynamic. Dynamic and subjective. Why they are dynamic? Because it changes every moment. If even a person, as you move from NIT mode to Gandhi Maidan, you can have variety of thermal experiences, variety of moods, variety of expectations. But while the air temperature, etc., is not changing, even if the environmental parameters are constant, your mood will change, your expectations will, your subjective factors will change. So these aspects are called psychological aspects, are called dynamic parameters. Physical factors in this definition, there were physical, physiological, psychological. The physical parameters are only 4. CAV, RH, TMRT. These relate to the urban thermal environment, the temperature, wind speed, relative humidity, and mean radiant temperature. These 4 factors are called physical factors. Remaining physiological, skin temperature, core temperature, I told you, sweat rate, heart rate. Then comes the subjective dynamic aspect. Psychological aspects are a lot of, there is a variety of these factors. So these 2 factors, the first factor is for the knowledge of thermal environment, the second is for the knowledge of human body, and the third is for the knowledge of subjective mind. This third one, the psychological aspect, shall be done only by the thermal comfort surveys. You can measure a thermal environment by installing some machines on your rooftop or on the road or field wherever. go home and come back in the evening. But these subjective factors cannot be done like that. They have to be in the forms of structured questionnaires on the thermal sensation scales. These scales could be binary, 3 stage, 5 stage, 5 point, 7 point, Ashra, whatever. So this is about personal factors. There are 6 primary factors which affect the thermal sensation directly. Out of that, 4 are these microclimatic and 2 are personal, clothing and activity. Clothing is for the insulation. This retards the exchange between the thermal environment and human body. The unit 1 flow is equal to 0.155 degrees centigrade meter square per watt. The explanation, the physical explanation of the flow, and activity is 58.2 watt per meter. So the human body is considered to have a surface area of 1.8 meter square, assuming that the total watt is generated by human body, if it is 52 watts, 58.2 watts per meter square, the person is said to be having a MET of 1. Usually a sedentary person, as we are sitting idle, we have a MET of 0.8 MET. Multiply this, so it will come to around 50 or something. While you are standing, we are exerting, we are producing 1 MET. While walking 1.2, and then higher activity like running, wrestling, playing, they go up to 7, 8, 10 MET per 10 MET during those activities. Psychological factors. The third is psychological factors. These are the factors affecting the assessment. So psychological factors, adaptation is the most important of these. Gradually degree of organism response to the exposure. It could be physical, physiological, and psychological again. Adaptation. Physical is reactive and interactive. You can change yourself. Usually, this physical adaptation is more suited for the indoor environment. You can change yourself, like you can undress yourself, you can take drinks, you can keep slightly walking if you feel too hot. Then interactive changing, you can open the windows, you can put on the fan, you can in the outdoors you can resort to a shaded location if you are walking in the sun. So these are the interactive. Then physiological adaptation, genetic adaptation, it takes generations. Can acclimatization is a matter of few days and weeks. You can change to a new thermal environment. Suppose you go to England, you are feeling the first day you are feeling very cold, the second day lesser cold, seventh day you get acclimatized and feel lesser cold. So this is acclimatization. This is a subconscious effect. You don't consciously change the physiological condition of your body to adapt to the situation. While this was conscious effort, physical adaptation was a conscious effort. Then psychological adaptation, this is again not a conscious effort. It goes in subconscious by your activity, by your exposures, by your daily routine, by your job condition, by your stay whether you stay indoors or outdoors, depending on your job conditions, like that. The factors, these factors had been for the first time proposed by Professor Nicola Polo in Cambridge in 2003. This was a pioneering work by her. I think we are lucky enough to have watched her presentation during our international conference a couple of years ago in the Gandhi Maidan. She was a participant in that. So this was first proposed by Professor Nicola Polo, and she has given 6 points, 3 primary and another 3 secondary, out of which these 3 are the primary points: naturalness, expectations, and experience. Naturalness is, say, suppose you are standing on the road and you are feeling certain heat provided by warm air. So that's provided naturally. And suddenly one truck passes and it throws a lot of smoke and dust. That artificial means of causing disturbance to your thermal environment is less acceptable as compared to the natural. Then it's about the natural elements in the visual field of the site also, like greenery, water bodies, contours. Then expectation. I have already spoken about the expectations. During summer, you expect it will be hot outdoors. So that expectation gives you a certain relief and you feel less discomforted by the no. This is experience. This is influenced by the previous experience wherever you have been, whatever thermal exposures you have had, like the rich age who are born in AC, who have never been outside, they will have a very poor thermal experience as compared to those who have been in a variety of thermal environments. Long term, and then there is short term experience and long term experience. Long term experience is stored in the mind called a schemata. It's a collection of knowledge patterns and expectations. Knowledge patterns and expectations. This increases your thermal empathy about a thermal environment, such that when you are encountered with such certain situations which are new to others, may not be new to you. You are used to that. You are aware with that. So you will be less discomforted compared to the others who are not with that kind of environment. So these are certain studies about the experience, and this is again some study about long-term experience, short-term experience, use of air conditioners. So use of air conditioners. This is a part of that. Hello. Hello. Am I audible? Hello.
Yes, sir, you are.
Okay. Use of air conditioners, again, this forms a part of the thermal experience only. Long-term usage and short-term usage. Long-term usage, those who have been in AC environment since long, they will have higher thermal sensitivity. They will be less able to tolerate the heat as compared to those in the short term. Say we are not, somebody is not accustomed to living in AC, but he has been for half an hour in the air-conditioned environment. If he comes outside, it will take him time to feel the heat. For initial few minutes, he will be okay with the heat, because lower skin and core temperatures will take time to uh, get in equilibrium with the outdoor thermal environment before he starts feeling the discomfort. Then the time of exposure, shorter exposure, okay, tolerable. Longer exposures, they are less tolerable, even if the thermal environment, thermal parameters may be the same. Somebody walking from maybe architecture department to head office building, it takes 5 minutes. You may be okay with that, but when you are asked to go to Gandhi Maidan, the time of exposure increases. You will, in the same thermal environment, you will be at discomfort. So that's the rule of time of exposure. Then comes perceived control. This is a very important aspect proposed by her. This is the ability to control the source of discomfort. Availability of the control, regardless of whether these controls are exercised or not. Suppose you are sitting in the room and the light is gone. Now you cannot put on the fan. This is one condition. The second condition, imagine the light is there and yet you have not put on the fan. You are thinking to put on the fan. The two conditions will give you different thermal sensation. When the light is gone, you have lost the control over the thermal environment. You will feel more discomforted when the light is gone in comparison to the case when light is there, still you are not running the fan. Since you know you can put the fan anytime on. That's about the perceived control. You can, in the outdoor environments, if you are standing, say, in the center of Gandhi Maidan, and you know the nearest shade you will get at the end of the Gandhi Maidan, it will take you 5 minutes to walk. The other person is standing on the edge of the Gandhi Maidan. You can walk few steps and get under the tree. He can get into the shade of the tree. So the two persons in the same thermal environment, in the same sun, standing in the same sun, will have different level of discomfort. The one standing in the center of the Gandhi Maidan, having lost control over the thermal environment, he cannot change the environment unless he walks for a substantial distance, will be at more discomfort. This is a psychological process. You can realize, you might have realized at places. So availability of controls can be two types: change the thermal environment and ability to choose. The change the thermal environment outdoors, you cannot change the thermal environment, you know. You can only choose the thermal environment. You can walk in the sun or walk in the shade. You can look for some street where there is some relief, some shaded wind, there is some wind, so kind of that. While inside, you can change the environment. You can put on your AC, you can open the window, you can do whatever. People sitting in thermally air condition at their free will were found more tolerant to stresses than those under some sort of compulsion. These are past. There are two researchers in Delhi. They had conducted the study. This is a very important study in the composite climate. New Delhi. They found non-worship. They had conducted their study, one in Hanuman Mandir Square and the other was Gurdwara Bangla Sahib. So both the religious square. He um, he has reported that non-worshipping visitors to the campus were having higher tolerance for increasing stresses compared to those with worshipping purposes. So what does it mean? Non-worshipping worship visitors were free to leave that and that was the freedom of choice available with non-worshippers. While those who had visited for a worshipping purpose, they were bound by their purpose. They could not leave unless their worshipping purpose was completed. So that binding upon the worshipping visitors made them feel more discomforted because their control over the environment, that perceived control factor was weaker with the worshipping visitors. So, and then another example, while I was conducting one survey in 2019, I had found the highest thermal neutrality in the botanical garden Patna, because all the visitors in botanical garden had no purpose. They were having leisure, their free time, they had come for entertainment. They could leave the environment anytime they wanted. So they were more comfortable than the visitors of the other nodes during my survey. Their thermal neutrality was some 5 degree pet higher than the others. That's based on my past survey. The last element proposed by Professor Nicola Polo is environmental stimulation. People get bored in monotonous environments. If you provide a variety of environments in terms of geometry, in terms of landscape, in terms of water bodies, or even if the nothing is available, you can change the colors, designs of the buildings. You create a variety of environments. Probably this is one of the points proposed by Kevin Lynch in the 5 points. So that alleviates a lot the sense of thermal discomfort. This is one diagram which I had developed based on the proposals by Dr. Nicola Polo. You can see these three factors on the left, naturalness, past experience, and perceived control. These are primary parameters. Then environmental stimulation, time of exposure, and expectation. These are secondary personal parameters. Mostly the personal parameters are affected by the primary parameters. While you can see these two digits, say in naturalness 4 and 0, this shows that naturalness is affecting 4 other parameters while it is being affected by none, 0. Past experience is affecting 4 other parameters, say time of exposure, environmental stimulation, expectations, and perceived control. Past experience is affecting, while it is getting affected by 2, time of exposure and environmental stimulation. So based on these two digits, the strength of the parameter seems. So that way naturalness seems to be the strongest, affecting all, it's getting affected by none. Past experience is affecting 4, getting affected by 2. Perceived control is affecting 3, getting affected by 3. Similarly on this side. So this is a very useful diagram. It was done in 3 parts. I have joined all the 3 diagrams into one to give these lines are called influence lines. So these are then the important thing is to note is that none of these diagrams or these relationships show any quantitative value. These are all qualitative. Professor Nicola Polu has herself declared it very well in that paper that she has developed in based on a common sense a speculative network, not weight related, and there is no magnitude associated. This is not I am saying, this is she herself has said it. So, but this is a very nice qualitative explanation of the 6 psychological factors that vitally influence the assessment of the thermal environment. These are some past studies which ascertain, which corroborate the existence of these psychological factors, experience, expectation, perceived control. Lot of studies have been done on these factors after the proposal of that theory, this psychological theory. Lots of studies have been conducted to verify those factors, but all of these are qualitative. None of these studies have provided any quantitative data to show how much is the effect of which factor and under what condition. So the next, apart from those psychological factors, there are lots of indirectly affecting factors. I have very briefly noted only the headlines here because of the time constraints. The behavioral factors, personal, socioeconomic, cultural, site, the psychology, crowd, mood, anesthesia, etc., etc. There are lots of. This is a summary. This is a diagram. This diagram shows the list of all those factors. You can note here in the left bottom 6 primary factors, out of which 4 are microclimatic factors and 2 are personal factors. These 6 primary factors are responsible for around 70 to 90%, minimum 70 to maximum 90%. 90% तो अभी तक नहीं मिला है, 85, 87 तक मिला है. But to say these 6 factors define the biggest percentage of that thermal environment, while remaining all are responsible for only 15 to 20% of the explanation. Here are the psychological factors that affect this thing directly. The remaining, you see these blue dotted line, blue dashed lines, the factors included inside the blue dashed lines, they are indirectly affecting, while those in the red lines are directly affecting. Indirectly means these factors affect the directly affecting factors. Say age. Age does not affect thermal perception directly, but it affects the metabolism of the body. Now on increasing age, the lesser the metabolic rate, lesser the heat generated, so lesser the sensation of thermal discomfort. That way, all these factors affect the directly affecting factors, and directly affected factors directly affect the thermal perception. Then to counts the role of thermal model. Thermal environment can be assessed by already said equivalent. These models are of two types: rational models and empirical models. Rational models are based on scientific computer data, confirmations, validations, etc. While these empirical models were based on, as Dr. Nicola Paul said, on common sense, etc. So, for our purpose, we will in this session we are only and only concerned with this multiple linear regression models, which will incorporate the role of the thermal environments as well as the role of the subjective models, and they will give a quantitative explanation of the role of each individual factor. Equivalent temperature models, this explains the thermal environment, like this PET, UTCI, etc. ये जो models हैं, these explain the thermal environment. Thermal load models was proposed by again Finger, PMV, predetermined voltage. This gives the sensation, actual sensation on the 7 scale, -3 very cold, 0 neutral to +3 very hot. So this to some extent is explaining directly the sensation of the human in the thermal environment. While these models do not, they not at all give the sensation, they are just explaining the nature of the thermal environment. What is the interactive result of the 4 microclimatic parameters together. Empirical models, again, this in 2003 only, she had shown the, so she had developed one equation by regressing 4 factors, 4 microclimatic factors, which to get the actual sensation votes, which she declared that this is not accurate. This is only to show that this kind of regression is possible, and based on that, later researchers have developed these models. See, this was in 2003. Now this is in 2016, 19, 18. So much later, after the she proposed this theory, the later researchers have, but all these are qualitative. Again, to say, none of them have provided any quantitative explanation. So then comes to quantification of psychological adaptation. It is possible to quantify the effects of physical adaptation. It has been proved by research that reduction in one's metabolic rate can be changed by 10% by consumption of cold drinks. This is one data. Temperature, comfort temperature range can be adjusted by 6 Kelvin. These are objective assessment of the physical adaptation factor, while quantification of psychological adaptation factors and their relative weight on thermal perception has not yet been possible. This can be recorded by field surveys, methodology proposed by previous researchers. But then, it is the important point to note here is that the quantification that we will be seeing in the later slides is not absolute quantification, it's relative. Means there will be categorical ordinal data based on which these quantifications will be done. So suppose someone is in a good mood, suppose mood is a factor. Someone in a good mood, someone in a bad mood, someone in a very bad mood assesses the same thermal environment differently. In that case, what happens that if you presume the good mood factor to have 0 weight, the other moods will give you a relative thermal sensation data to explain the role of mood on the thermal sensation board, thermal perception board. So this quantification will be only relative, not absolute. So, as said previously, this subjective assessment can be done only through surveys. A survey was conducted in 2019. I had conducted for my PhD purposes. The results in the following slides are based on that survey only. A thermal sensation prediction tool was proposed incorporating objective and subjective factors. So, quantification of the factors. This is a brief description of the methodology. The survey site in Patna attempted from far east to the west as far as possible. Variety of sites, variety of respondents were selected. Sites were right from educational to institutional to office, botanical garden, this is leisure, then Gaya, transportation. Routes and resting places is the concept given by one researcher again. Routes and resting places were considered. Resting places may the botanical garden, workplaces, cultural centers like Harimandir Sahib. All varieties of sites were selected. The total sample size was 1104. Survey was conducted in January to July 2019. The methods adopted were statistical procedures, time correlation, Pearson correlation, regression. For the non-parametric test, Mann-Whitney test for the binary data, Postal-Wallis for the multi-scale data. Then regression was conducted by two methods, stepwise regression and best subset regression. At the best of the two was selected. So I found that forward selection with validation was giving me a more robust model. I selected this method with 20%. The whole data you are also sure 1104 was categorized into two bills, 80 in the ratio of 80-20. 80% was used for creating the model, 20% was used for the validation of the model. So then consistency check was done and the final model was. I didn't have instrument for measuring the radiation, so radiation was modeled in Riemann probe. These are the variables that were investigated during the survey. Time of exposure, we have seen these factors in the previous slides. Time of exposure, experience, thermal history, perceived control, age, gender, etc. Mood, naturalness, crowd. Some of the factors we could not discuss in details, but these were included in the survey. The effect of crowd, this has a very vital role in the assessment of the thermal environment. So why this regressed model? You see, in the same survey, by using the data of the same survey, when I calculated the mean thermal sensation volts using the four physical parameters, that is TA, RH3 and TMRT, the model that I got had R square value of 85.11%. That shows 85% of the thermal 85% of the process of thermal perception was explained by this model containing four parameters. This, I have given this address of my thesis where the details can be seen. All the details cannot be discussed here. Those interested can refer to this handle. Neutral temperature was calculated at 2 squares in New Delhi. I said they got this R square of 0.7 only. They again had to use the four microclimatic variables. So this is the order which we get 0.7, that is 70%. So I got 85%. Somebody could get 88%. Nobody has crossed 90%. I know that. We can get maximum 87-88% of R squared with these four physical factors, using these four physical factors. So the need to, so that shows there are some other factors affecting the perception. This shows you can have, there are lots of plenty of thermal comfort researches available on the net. You can find it, you can refer to them. None of them have got R squared values more than say 87, 88%, 90% nobody has got. So that shows the need of this study. Why this regressed model is required. Now I regressed the model with incorporating, initially I incorporated 26 number of variables candidate predictor, but not all of them were significant, so I had to gradually remove them. So this shows the removal process, and at the last the you see, after removing the last insignificant predictor, I got an R square value of 94.2, which is substantially 9% higher than this. So this 9% of higher explanation of the thermal perception by adding these factors, there are 13 of them that have been included in the model. You see, here it is. Here is the model. So if you count, in addition to the constant and the 4 physical factors, there are 13 variables incorporated in this model, and that raises the R squared value to 94%. But yet 5.8% deficiency is there in this model also. That shows that there are more factors involved in the process of thermal perception, which need to be incorporated in this model, and that's a task for the future researchers. They can go ahead and find out more to increase this R squared value. So this is now here. If you see what I was talking as the absolute values of the absolute values, I think it will be better visible here on. If we see, this is only a graphical representation of that of the constant that are here in this model. So if we see the on the left is the mean thermal perception volt. This is in decimals, because you know the coefficients will be always in decimals. The highest factor, of course, in this model is the wind speed, more than 0.75, 0.787 something. It was the wind coefficient was 0.757. Highest factor is the wind, then air temperature, followed by mean radiant temperatures. Contribution is very less. This is a unique case in my survey, because I had conducted all my surveys in the shade. None of my respondents were exposed into the direct sun. So probably that is why the role of mean radiant temperature is not as prominent here. Otherwise, this should have been prominent. Then next to these 4 physical parameters, if you see the highest factors are one experience and the other perceived control. Of course, age also. Age is also there. This shows 0.3 above, more than, numerically it is more than 0.3, though it is in negative. So what happens that you can see above 0 the positive value and below 0 the negative value. So when the speed has got negative value, this is in concurrence to wind speed. More the wind speed, it relaxes the thermal sensation, so it reduces the thermal sensation volt, thermal prediction volt. The negative, all the negative values that are lying below the 0 line, they go in reducing the perception of thermal environment, like age. Higher the age, lesser the sensation of thermal distress. Then here is FOV, frequency of visit. Frequency of visit is one factor which shows your acquaintance with the site. The more you are acquainted with the site, with the thermal environment, higher is the FOV value, and higher the FOV value, lesser the thermal strain. You see the last fifth variable on the ordinal scale has the numerically biggest bar. This shows almost 0.3. So those persons who visited the site more than twice per week felt 0.3 thermal sensation less than the one who visited once in a year. So this is a relative statement of this quantification is a relative statement of the thermal strains as felt by the same person in different conditions. And say here, this is based on the employment. So office bearers, laborers. Laborers are feeling least thermal discomfort because of their thermal experience. This role comes into play in the profession here. The thermal experience. Laborer is mostly exposed to the outdoor environment, working in the sun, working in the rough weather. So his thermal experience being richer, he is more comfortable with his thermal tolerance is higher than as compared to the office bearer, the businessman, or the retired occupant, the retired person, or a housewife or a house person. So that way, it gives a relative quantification of the thermal sensations. These are not absolute. Absolute measurement of a subjective factor cannot be possible. But yet, based on the number of respondents, if you get sufficient number of which 1104 in my case, you can conduct survey with still higher number of respondents and to get more sturdier model and claim bigger accuracy of your model and thus give a statement of the role of the different factors like occupation, age, frequency of visit, or here crowd, greenery, mood, etc., etc. You can quantify this in a better way by maybe incorporating more factors into the model and incorporating more number of respondents. So the number of respondents that I had selected had a confidence level of more than 99% with a prediction of error 5%. That prediction of error can be reduced by increasing the number of respondents. It could be brought to 3% or it could even lesser. That scope is there open for the future researchers, students, and whosoever. Here, one more thing I would like to point out here is that there is this one factor, naturalness, the perception of green. It has got a very feeble role here in this model. This is weaker than the perception of crowd. Perception of crowd has got more weightage here in this model. This is because most of my sites that I surveyed had very feeble greenery, while the crowd was abundance on almost all the sites. Almost all the sites. That again can be further modified by making the surveys at still new varieties of sites with having more greenery, less crowd, and other varieties. So that I think explains the role of different here. These are all non-physical factors. Only 4 are the physical factors on the left. Rest are all non-physical. So this is a relative quantification of the role. Then we are approaching the end. as I said, 5.8% still unexplained. So future research scope is there. Greatest explanation is given by the four physical factors. The strongest predictors have proved to be experience and perceived control. Okay, freedom of choice. So one needs to do something on experience and perceived control if one wants to improve the sensation of thermal perception. You want to improve the thermal perception and to increase the tolerance, one has to increase the experience and perceived control. We will see their urban design implication. These two factors have a lot of urban design implication. We shall see later. Age and occupations were found. This much data as you have seen. Crowd and tidiness. Tidiness of site were contributing to the filthiness is not only unpleasant to the eyes, they enhance a sense of thermal discomfort also. This is a unique finding here that we have found in our survey. Mood and greenery, of course, they contribute to the sensation. Neutral pit was in the humid months. This was done in the, as I had said earlier, in the botanical garden. We have found a neutral pit of 36.8 degrees centigrade, which is substantial higher than the overall pit, that is 31.2. This is more than 5.5 degree ka difference. This is influenced by the two factors, naturalness and perceived control. This has resulted in the increase of thermal tolerance by 5.5 degree PET. This is a unique finding in this survey. Cultural factors also have, you see, 2.7 degrees centigrade of neutrality difference was found by Manavi and Rajsekhar in New Delhi study at the two religious squares between the worshipping visitors and non-worshipping visitors. So the perceived, this shows the cultural factor as well as perceived control ka role hai. This affects your thermal neutrality by 2.7 degrees centigrade. Composite neutral pit is found 31.2 degrees centigrade, which is 0.7 degrees centigrade lower than that from warm humid Chennai. This research, they had found 31.9. This is a research by Dev and Ramchandraya. So, but much higher than those in temperature. This is a comparative statement of genetic adaptation. These data show the effect of genetic adaptation. Neutral pit, and again this Delhi study has found two neutral pits, 26.4 and 22.1 in the same place, same New Delhi, you know, between the two communities. As I said, one was Hanuman Mandir Square, Hindus. The other was Gurudwara Bangla side, 6. And I guess, so these researchers have not stated this thing, but I guess this difference is because the Sikhs in Delhi are much richer community than the Hindus. They are more exposed to AC environments, the Sikhs. So their thermal neutrality is low, 22.1, while those visiting in Hanuman. So that's an effect of past experience again, AC का effect है ये. New Delhi पे this is a very important thing. At New Delhi, 1 unit change in thermal sensation votes is manifested by 2.8 और 3.2 डिग्री सेंटीग्रेड चेंज इन PET, while पटना में हमारे यहाँ 9 डिग्री सेंटीग्रेड पर ये अफेक्टेड होता था. So that shows कि हमारे पटना के जो respondents थे, they were much more sturdier and tolerant of heat than those compared to the respondent at Delhi. Why? Because that's because of the socio-economic conditions. This is not based on my research, but that is my speculation. There cannot be, because most of my respondents were people from lower middle class or labor class or kind of that. So they had definitely a higher thermal tolerance as compared to those visiting the Gurudwara Bangla Sahib in Delhi. The next is neutral pet of AC environment. So 28.8 was found 2.60 that non-wind 21.4. This was found in case of the gap increases directly with increasing pets. This is consistent with the findings of this was in our research by in AC वालों का neutral pit lower था as compared to the naturally ventilated people. The difference was 2.6 degrees centigrade. This again corroborates my speculation about that Delhi research in the previous slide, where they had found this 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 this, difference of thermal tolerance. This is because of the exposure to AC environment. Thermal neutrality were found increasing for different occupations group. लेबरर्स से सबसे ज़्यादा टॉलरेंट थे, उसके बाद रिटायर्ड वाले, उसके बाद हाउस रिटायर्ड वाले का कारण क्या है? बिकॉज दे आर एल्डरली पीपल, तो एज we could see in the this thing the age is a factor which higher the age higher the thermal tolerance we can see here. So retired people because of age also have higher thermal tolerance. So found here housekeepers and students and officers. रूम इफेक्ट है कि जो हमारे डिग्रेडेशन लाइंस आते थे they converge towards a point with increasing pit. So these all this theory, this gradation in thermal sensation holds good only till the pit conditions are lower. On higher pits all this becomes merged together. The factor education shows a statistically significant gradual drop in thermal neutrality and rising in empathy with increasing education level. But with education level, people become more fussy about their health and all that. So that's probably one explanation I had read somewhere because of that. Females were found to have higher thermal sensation. This is corroborated by many other previous studies I had also found. But these are the assessment. And now to conclude our discussion, let us come to some urban design implications. How these findings, what do these findings imply in terms of urban design or architecture? Urban assessment of greenery and preference for urban or rural environments was found decreasing thermal sensation, thermal sensitivity, etc. जब ग्रीनरी जैसे ज़्यादा होती है तो थर्मल सेंसेशन को वो रिलैक्स करता है. फ्रॉम 1 to 5 ये है. Though quantitatively it was very less, but though it existed. So greenery can alleviate the sensation of thermal distress in the urban environment. So we need to increase the greenery. This is one aspect. Then sensation reported respondents especially the green in studied premises 2 while low disadvised had a MTSV of 2.4. This difference of only 0.48. This was reported by Rajshekhar in Delhi. Perception of place का भी रोल है. A site's appearance interferes with the felt thermal judgment. Appearance has a role in the sensation, thermal sensation. So tidiness and aesthetic appearance are important. We need to create aesthetically superior places by whatever means, by changing proportions, changing geometry, by use of soft landscape, water body, whatever. Then comes the effect of crowd. Crowd is reported to increase thermal sensation by a previous study on the railway platform. This was Brown and Parsons in 2009. In my study also, crowd has affected the this thing, thermal sensation badly. You see here in the last, the extreme right, very light people have reported the least thermal sensation, and that is on the scale MTSV of 0.2. So crowd has an important role in the thermal sensation also. We need to design places such that they are not crowded. I don't know how to manage that. Population तो बढ़ता ही रहा है, crowd तो बढ़ता ही जाएगा, space limited है, but that is one finding. based on the three primary parameters proposed by Professor Nicolopoulou. Naturalness is one aspect which is not affected by others, but it affects the thermal sensation substantially. So greenery, water body, natural contour, CTC, natural, जैसे भी आप naturalness बनाना है, you can use creepers on your walls, you can have green walls, you can have, by whatever means. Experience can be influenced by rich spatial variety. Rich spatial variety क्या हुआ? You can create urban realms with changing proportions, changing scale, changing color, changing texture, changing whatever means. You can create varieties of expectation. Of course, this aspect is not perceivable by standing in one place. This is for those spectators who move around in a place and who like to gather different kinds of thermal experience, but provided you provide them. So in the urban design, the spatial variety is not only good, conducive for the eyes, it's not only aesthetically appealing for the emotional welfare, it's also good for the relieved sensation of thermal experience. Then perceived control can be enhanced by creating variety subspaces, sunny, shaded, windy, wind stagnant zones. You can create different kinds of zones by utilizing the wind direction, prevalent wind direction, the solar altitude, azimuth, depending on the location of the place. You can create shades, you can create sunny spaces to be used in winters or in summers alternatively. So these kinds of variations, if created in the outdoor spaces, they will substantially alleviate the stresses created by thermal sensations, by the thermal environment, which otherwise cannot be changed. You can put awnings, parasols, movable elements also, which we usually find in foreign countries. And the last implication is the human implication. Increase your thermal tolerance. That can be increased by moving into the sun. Do not rush to putting on your air conditioner of the car, even at the slightest feeling of a discomfort. And that is the preach Lord Krishna, the Creator, gives to Arjun in the Gita, chapter 2, verse 14. Matra sparshaastu kaunteya sitoshna sukha dukkada agama paino nitya stansu bharata. This verse was written, I mean not written, it was preached in Kurukshetra, you know, that is that falls in Haryana, composite climate. Composite climate is characterized by what? Transience of the climate. So Lord Krishna says, Agama paino, anityas, anitya hai ye, इनको सहन करो, इनकी प्रतीक्षा बढ़ाओ, सहन करो, increase your thermal tolerance. So with that preach given to Arjun by Lord Krishna, having said that, I end my discussion. Thank you, Jai Krishna. Now, any questions? Shubham?
Thank you so much, sir, for sharing your insightful research with us.
Thank you.
The platform is open for question answer session. If anybody have any kind of question, please interact with the speaker and you can ask your questions.
I think
Participants, please, you can ask the question if you have any kind of question.
Good evening, sir. I have a question. How should urban planners or architects incorporate thermal comfort variability into building design?
Thermal comfort variability. What is variability? You need to achieve thermal comfort inside the building, na? Hello.
Yes, sir. Yes, sir.
You need thermal comfort inside the buildings, or you need thermal comfort variability inside the building?
Sir, the question is for the thermal comfort variability inside the building.
Thermal comfort variability inside the building can be achieved by creating differently ventilated, differently oriented buildings. You can expose certain parts of the building to the westerns, and that will become less comfortable. So you can expose certain parts of the building to the northeastern wind that is prevalent in Patna. That will be more comfortable. So that variability is very easy to achieve. But I think that was not your question, to create variability. You want to achieve thermal comfort throughout your building, no?
Yes, sir. Yes, sir.
So the task, main concern of the architect is to achieve thermal comfort throughout the building, in every part, every nook of the building, and not varying thermal comfort in the building. No? So for that we have different devices: the waste protection, white trellis, creepers, trees. South side we have chaja, since the altitude is high during summers. So even a slight projection of chaja can protect the entire wall from the direct insolation. The main issue remains the western, but the north is already protected in the north hemisphere. So you don't need to bother about protecting north. Then comes the terrace. The terrace can be protected by means of green roofing. Nowadays, it's a common fad to provide green roofs by creepers. By the best protection is given by no artificial means, but by the natural means, that you provide creepers or plants. You cover your terrace with the plants. You can best. So that terrace is probably the widest gateway through which insolation or the solar heat penetrates the urban area. So the protection of terraces has become a great challenge in today, because walls are not that big a problem, especially the three sides, north, east, and south. Only it remains only the western part. When in the afternoons, that when the environment gets heated, you need to protect the western walls properly, and that can be done by vertical louvers at the worst. Nowadays, we have aluminum products which are better heat repellents from the buildings. Previously, we provided RCC chaja, which somehow or the other absorbed the heat, and through conduction they imparted the heat inside the building also, so in a certain lesser percentage. But nowadays, aluminum claddings, aluminum files, they do not convey the heat absorbed by them into the building. They are very less. So these are the recent materials, invention of recent materials you can use to protect your waste. You can use them to protect your terrace also. No issue. You can provide pergola, etc. on your terrace. So these two are the main issues. Then you have to orient your building for the natural breeze. Ventilation is of two types. You must have read the pressure ventilation and the natural ventilation. You can create a stack effect to take advantage of the cool breeze that is existing outside. That may not be existing outside. Depends on the terrain that is surrounding your building. That depends on the vegetation, on the grass covers, on the soft landscape, on the moisture content, the buoyancy ratio of the soil that surrounds your building. But if you are unfortunately surrounded by hard landscape, roads, pavements, then you cannot probably use that stack effect also, because that will your building will be ambient with a lot of warm air on all the sides because of that pavements and hard surfaces. But if you are lucky to be in a place, in a colony where the buildings are sparse, where there is a lot of plenty of soft landscape, grass covers, you can use that stack effect ventilation, even if there is not breeze available in your area. That stack effect works very well. This Professor Karan Grover, Professor Karan Grover, who had designed our this assembly building, he had once claimed that he had created one building which cooled the interior of the building by 12 degrees centigrade. That's a substantial amount of cooling by passive means, so far heard of, at least by me. He had claimed that in 2005 when he was here at Patna. So there are these already well established contrivances for the passive cooling of your buildings work well, provided we adopt them. But because of the commercial reasons or whatever, we are not able to exploit the stack and all that effect. But the purpose is to achieve that passive cooling only, and of course you have to first keep your outdoors to a subdued stress level. Then only you can probably effectively cool your inside of the building without using mechanical contrivances. So that way, both ways, you have to treat the interior as well as the outdoors also. We have just spoken about it.
Thank you, sir.
I hope.
Thank you, sir.
Thank you.
For sure,
I hope I have
for
answered.
sharing. Yes, sir, for sharing the knowledge on the topic. And also, sir, you have worked upon on the pedestrian comfort. So, any specific reason for selecting the pedestrian thermal comfort?
Pedestrian thermal comfort, that कोई भी outdoor, any outdoor environment which has to be pacified in terms of extremities of the weather has to be done passively. Now, whether it be pedestrian or a sports field or any outdoor space, it could be a park, it could be anything. But my research specifically on pedestrians, ऐसा तो नहीं है कोई भी, but pedestrians need to be provided proper cooling in the outdoor environment, because if you have seen my presentation, there was one transit point, the service near Gaya, that transit people are exposed to a psychological mentality that they have to accomplish their work. So they feel the hit lesser than those compared to idlers. But still, they need to be provided comfort. But pedestrian comfort पे ऐसा तो नहीं है, पेपर नहीं हुआ है, pedestrian पे नहीं हुआ है, because it is regarding the morphological design incorporating trees and buildings, the different kinds of urban developments, organic, planned, etc. etc. पेडेस्ट्रियन का भी होगा, देखेंगे फ्यूचर में, अभी तो नहीं है.
Thank you so much, sir. Any other participants have any kind of question? I think, sir, there are no more questions. We should conclude the session. Thank you so much, Dr. Venkatesh Raman, for that insightful and engaging session. Your talk on quantification of the non-physical factor affecting assessment of urban thermal environment outdoors, truly highlighting the importance of user perception and psychological factor in designing thermally comfortable urban spaces. We appreciate the depth of your research and the clarity with which you shared your findings. I would also like to thank all the participants for your attention and active involvement throughout the session. Before we wrap up, a quick announcement for tomorrow. The session will begin at 9:30 a.m. So we can encourage everyone to join on time and another enriching session. Thank you once again and have a great evening.
Thank you, Sean. Thank you very much. Thanks all the participants for listening patiently to me.
Thank you so much, sir.
Thank you.